Okay, this is our last problem in chapter 4. Let's try to solve this. It's dealing with net force, gravitational force, and normal force. Alright, a 60 kilogram woman in an elevator is accelerating upward at a rate of 1.2 meters per second squared. So we have an elevator, and we have a woman inside of it. Remember, I suggest drawing out all the problems. I'm drawing a skirt, not that women should wear skirts all the time, it helps you see that it's a woman. And she's having a bad hair day today. Okay, so she's standing here, she's being accelerated. Let's do acceleration in blue. So she's going up at 1.2 meters per second squared. That's not a force, that's just the acceleration. Okay. What is the net force acting upon the woman? Well, net force, I know it talks about some different things here, but we're just looking at net force. Net force, Fnet, is equal to all your forces added up, so like F1 plus F2 plus F3, or just like any other force, your force is equal to your mass times your acceleration. Okay, well let's write down the things we know. We know the mass of the woman is 60 kilograms. We know her acceleration is 1.2 meters per second squared. Oh, well, let's use this equation right there, because that has the Fnet, which is what we're looking for. We don't know what the Fnet is. Let me write that down. And we know it's equal to the mass times the acceleration. So let's plug in here. We got Fnet is equal to 60 times 1.2. Our unit would be newtons because we have kilogram times meters per second squared. So let me get out my calculator here. 60 times 1.2, we get 72 newtons. That's our Fnet. That's our net force. So I'm gonna move this. I'm gonna say do red. Oh, I want that back to blue. Let me grab a pen. I'm gonna do the pen. So I'm gonna draw the forces in red. So the net force acting on the woman is 72. Alright, so that's why she's accelerating upwards. And if you weren't sure about, okay, whether it's upwards or downwards, up I said was positive, down is negative, so acceleration is 1.2 up, so it's positive. If you had a problem where the acceleration was down, you'd call it negative. Alright, so this is going up. Now let's try B. What is the gravitational force acting upon the woman? Well, the force of gravity is equal to the mass times acceleration due to gravity. So I'm looking for F of G. The mass of the woman is 60 kilograms. Hasn't changed. And the acceleration due to gravity, not what she's actually accelerating, but the acceleration due to gravity is 9.81 meters per second squared. No, she's not actually accelerating at that rate, because that's not the only force acting on her. Force of gravity is not the only force. But still, yeah, the acceleration due to gravity is that. That's a constant. So we can find the force of gravity. Let's take 60 times 9.81. Our unit will be in newtons. And let me get out my calculator. So 60 times 9.81. It's going to get us 588.6 newtons. Now, is that her, okay, that's newtons, but remember these things have to have a direction, so my force of gravity is always acting toward the Earth. So force of gravity is always going down, the Fnet, and that's 588.6 newtons. I'm going to say that's down because it's toward the Earth. So this can be a negative. Well, it's negative compared to the Fnet, which is going up, which is positive. We can have them flip-flopped. That's okay, but by convention, I usually have up as positive, down as negative. All right, so that's B. Let's try to do C now. It's not so bad. And remember, we're going back to that force equals mass times acceleration. That's what we've been doing. What is the normal force pushing upward on the woman's feet? Well, we don't really have an equation per se just for normal force. So what are we going to do here? Well, let's think about what's going on here. We have her going up, her going down. Remember, the normal force is going to be equal to or greater than the force of gravity pushing on her. In this case, or it could be less, but in this case it's greater because we're going up. So if that doesn't make sense, maybe let me look at the equation. Show you the equation here. Fnet, the net force, is equal to all our forces acting on this woman. Well, we know one of them is the force of gravity. That's what's pulling her down. Well, what's pushing her up? The elevator's pushing her up. So the thing that's pushing her up here, that's the normal force. Okay? That's the thing that's pushing her up. Back up this way. It's the normal force. Just like with the table and the problem before, it's what's pushing you up or keeping you from falling. It can push you up or keep you from falling or slow you down. So we also have the normal force. Black. Okay. So that's the forces acting on this woman. We know these are not equal to 0 because we have an acceleration. So let's plug in the numbers that we have here. We know what the Fnet is. That is 72 newtons up, positive. The force of gravity is negative 588.6 newtons. Then we have the normal force, which is what we're solving for. It's all of our forces acting here. And if we solve for this equation, look, we got the numbers plugged in. Just add 588.6 to both sides. So what is that plus 72? 660, just about 0.6 newtons equals the normal force. Which you're like, well, does that make sense? Not make sense. So let's look. So she's getting pushed up by the normal force. That's what's pushing her up. The force of gravity is pushing her down. That's the two forces acting on her. The net of that is the Fnet, the net force. So yeah, this should be 660.6 because it's a little bit greater than the 588.6. So you have, this is like your extra. So much is going up, this is positive. So much is going down, your extra is the Fnet, the difference between these two. And that answer makes sense. This should, the normal force should be greater than the force of gravity because she's accelerating upwards. Alright, so that's your answer. We actually answered all of those.